Hello students, in this video we are going to look at analysis of variance or ANOVA. So analysis of variance that will enable us to test the significance of the differences among two or more, in fact more than two sample means. So whenever we have more than one samples or more than two samples, then we are going to be using ANOVA. So in that case, our null hypothesis is going to be H naught mu1 equal to mu2 equal to mu3. That means the three samples are coming from the same population and they have same population means. And alternate hypothesis is mu1, mu2 and mu3 are not equal. So when we want to solve this, we will be using Excel for this. So I will quickly explain you the theoretical aspects first and then we will go to Excel. So in this what the formula we are going to use is of that of variances and that of uh, variances when we have a frequency also available. So there are two estimates we are going to use. You will understand it better when we take an example, but the first one is between column variances. Every column represents one particular sample. So between column variances will be given by this formula, and then we have another estimate is within column variances. So this is the second estimate of the population variance where we are using within the column variances. Now how to use this in actual practice I will show you when we are doing Excel. In this case N stands for the numbers and K stands for the number of samples. So K stands for the number of samples. Nj is the size of the jth sample. So you can have samples with different sizes also, right? And we are going to be using F distribution or F table for this particular solution, and F is actually a ratio of these two estimates. And when we are doing this F ratio, we have to make sure that the higher estimate is put in the numerator so that the F value will be always more than 1 or equal to 1. So between column variance, within column variance, again F statistics, but we can even interchange this if the F is coming less than 1. We have to ensure that F is coming more than 1. Then whichever is in the numerator, for that degree of freedom will be n minus 1 if it is between the samples, and if it is denominator, if it is within column, then it is nj, means total, uh, you can say minus 1 sigma of that, if for individual sample minus 1, so it is total n minus number of samples. Okay, so why we are finding out the degrees of freedom? Because in our F table we will get the value of theoretical value of F using this numerator and denominator degrees of freedom. So when we have this, this is our F table, and if you clearly see, this is the F table for 5% significance, that is 0.05, right? And uh, when we want to find out the F table, we have to look at the degree of freedom for numerator and degree of freedom for denominator and look for the table value. And when we have the two values, the F ratio which we calculated, which is a calculated value, and the table value which is our critical value. If F calculated is less than the critical value, then we accept the null hypothesis. That means there is no significant difference between the samples population means. In other words, the three samples are part of the same population. If F calculated is falling in the rejection area, that means beyond this, then there is a significant difference between the three population means. That is how we reject the null hypothesis and accept the alternate hypothesis. Now let us go to Excel and understand it from the real example how to go about it. So we have this problem where we have uh, the situation is like this. There are three centers. Maybe you can say they are teaching the same course. For example, you have PACE Andheri Center, you have PACE Dadar Center. PACE is the one which prepares the students for IIT entrances, right, in Mumbai. So we have three different locations: Center 1, Center 2, Center 3. And then there is a test taken among the same test is given to all the students. And in Center 1, they have got this 15 students and they got these results. These are the marks. Center 2, there are 14 students and these are the marks. Center 3 also, there are 14 students. These are the marks. So these are our three samples or three columns. So clearly we can first find out the mean and overall mean. So overall mean, when we take the entire thing, we will get the average. This overall mean we have to find out, right? And also we need to find out, once we have this means for each column, we have to find out the square difference, right? So we have to find out the square difference, which will finally make us give us the variances. So we have the square differences, and this is the uh, the total count, the squares, the sum of all the square differences divided by the count, which gives us the variance, minus 1, count minus 1, because this is a sample, so we will use n minus 1. So we have got this variance for our sample 1, this is variance for sample 2, this variance for sample 3. Then we have sum of squares between the groups. When we are doing this particular group and overall mean, we can calculate that. And then also the same formula we'll use, that count of this and into the this plus count of this into, so we will get the sum of squares for the entire thing. And sum of squares for the within the groups is calculated using this, the total of this. So now we set up the table for calculation of ANOVA. This is our summary of the count, sum, averages and variances for the three groups. Okay. In the ANOVA table setup, we use the sum of squares, which are calculated here and here. So we have got this sum of squares. Then degree of freedom, because we have three groups, 3 minus 1 is a degree of freedom. Total we have 15 plus 14 plus 14, 43 minus 3. So that is the degree of freedom for within the groups. And clearly our between the groups is on a higher side, right? So we will be taking the f calculated will be this divided by this. The ratio of this divided by this will be the f calculated. If you refer to f table, we will get f table is 3.23. So clearly the f calculated lies in the rejection region, and we reject the null hypothesis. Our null hypothesis was the three sample means, population means are uh, equal. So we are going to reject that, and we can clearly see that there exists a significant difference among the three samples. But when we are using Excel, we don't have to really do all this stuff. We have a simple function which I will show you. First, what you need to do, you need to select your data. Okay, so this is your data you have selected. Then go to data, and data, under data you have to go to data analysis. Under data analysis, on the top you will see ANOVA single factor. So go for that and you will say okay. labels in the first row because we have labels in the first row. So tick mark this, and the input range we will select again this, right? This is your input range, and that's it. And your significance level is 5%, alpha is 0.05. And when you say OK, one more sheet will open, and this is what is uh, our ANOVA using Excel. So it's so simple. So you will see that you have got the same sum of squares, 292 and 1431, which we calculated, and we also got this F critical and F table, and clearly the p value is 0.02. So the moment p value is less than 0.05, which is our significance level, we are going to reject the null hypothesis. So in this case also the result is same, that we are going to reject the null hypothesis, and we are going to say that alternate hypothesis is the one which stands, and the means are not equal for the three samples. The population means are not equal for the three samples. So this is how we calculate one-way ANOVA. Thank you.